Hello Year 11 and welcome back to the third installment of this thrilling series of videos on the harder examples from Chapter 1, right, now basic algebra. So here we have been looking in exercise 1C, we've been looking at factorising. Okay, so let's have a look. This is a really important thing for lots of work that we do in the tutor course, in the advanced course. We need to factorise things a lot. We need to become pretty familiar with these terms here. So let's have a look at some more difficult ones. We are told that each of these will be the product of 3 factors. And there's a few different things. So let's just try some, see how we go. 7a here, right? 7a, I have 3a squared minus 12 common factor. Always look for a common factor first. I can take a 3 outside of a squared minus 4. And of course that is a difference of 2 squares, which is 3 outside of a plus 2, a minus 2. There you go, so it was pretty fun. Something a bit more interesting. Oh, I don't know. How about b? Right, really excited about it. Moving on to the next one, but x to the 4 minus y to the 4. We don't have a difference of 2, I don't know, quads or whatever those things are, right? But I could think of that as x squared. Okay, so that's equal to, we could say that's like x squared plus y squared, x squared minus y squared. Okay, so this is, you know, we say that a is x squared and b is y squared. Okay, because if I square this, x squared squared is x to the 4, y squared squared is y to the 4. Okay, so I can do that. Now I have this here too, right? We are told there are going to be 3 factors. I can't do any more with this. X squared plus y squared. Can't do any more with that, but I can here, right? And that is, so we've got x squared plus y squared outside of x plus y, x minus y. There we go. So there's our 3 factors. Don't try to go further with this. You can't. Okay, you can't go there. You need you'd need 2xy in the middle to get a perfect square, or minus 2xy. That would work as well. But no, can't do any more with that. This here, the difference of squares we can. Keep in mind, difference of cubes. It's another exercise. Sum of cubes we can, not a sum of squares. Which one shall we do next? I know what you're thinking, Stan. Well, why didn't you organise this beforehand? Well, you know, that's just how it goes. Let's have a look at h. H. Put an h. A to the 4 plus a to the 3 plus a to the 2 plus a to the 1. Gee. Well, I could take a common a out of all of that. We go a outside of a to the 3 plus a to the 2 plus a plus 1. Okay, well I can do that. What else could I do? Well, maybe we can group by pairs. A equals, this is not very scrappy. Let's take a further no, I don't like that approach. You know what? This is a weird sort of question. I don't like that approach. I am going to take a to the 3. Right? Truly, I haven't thought about this very much. Got 4 terms. Look for a common factor. I do have a common factor of a. So yes, I was on the right track. Common factor of a. Let's do that. That is what we do first. A to the 3. This is really a good use of your time. Watching me change my mind about how to answer these questions. A plus 1. Okay. Common factor. Done. Next thing we look, I've got 4 terms there, so that's usually a grouping by pairs, or grouping in pairs sort of an operation. I'm going to take this a here. Here's a bigger bracket here, big square bracket. Now I'm going to take a squared out of the first part. A squared outside of a plus 1. And then I've got, oh look, I'm going to write it as plus 1 outside of a plus 1. Okay, big bracket there, equals a outside of a squared plus 1 outside of a plus 1. Oh, that's pretty neat and tidy, isn't it? You could expand that out and you'll get a to the 4 plus a to the 3 plus a to the 2 plus a. Wonderful, I haven't seen one like that before. Finally, should we look at something quadratic-y? Let's have a look at k. Okay, because you are smart people, and k is a little bit interesting. X to the 4 minus 3x squared minus 4. Well, you know what? We don't factorise 4th power polynomials usually, but Let's use a substitution to make life a little easier. Let's say, let a equal x squared. Why? Because, well, and we can say this is a squared minus 3a minus 4. Right, then my expression is that. Okay, so it's just to sort of help us see that this is x squared squared. So instead of factorising this and getting a pair of x's inside our brackets, we can have x squareds. So now we've got this. So I've got this quadratic. I can do this. It is going to be. It's going to be -4 plus 1. A minus 4. A plus 1. Okay. Which is right. Let's put the x squared back in there. X squared minus 4. X squared plus 1. That's not 3 factors. No, difference 2 squares. X plus 2. X minus 2. Can I do anything with this x squared plus 1? No, that's just the sum of 2 squares, and I can't do anything with that. X squared plus 1. Lovely. I told you you're smart. There's some, slightly more interesting factorising going on there. Again, check them out. Hopefully it makes it easier to do the hard ones, but hopefully it also makes it easier to do the easy ones. Okay, check out the next video.